Today we are going to discuss about the semiconductors. What are semiconductors? Why we are discussing about these semiconductors? The semiconductors are the intermediate materials exist between the insulators and also the conductors, whose electrical conducting property is lies in between them, and these materials resistivity is changes from the 10 power minus 5 ohm meter to 10 power 4 ohm meter. Generally, if you take the conductors, in the conductors electrical conductivity is depends upon only the negatively charged particles, that is electrons. But if you come to the semiconductors, in the semiconductors the electrical conductivity is depends upon the two types of charge carriers. One is negatively charged particles, electrons, and another one is positively charged particles, those are holes. First of all, we have to know about the semiconductors. Yes, we have already discussed that semiconductors are the intermediate materials, okay, whose electrical conductivity exists in between the insulators and conductors, okay, based on the electrical conductivity and also the energy band gap. We are classifying the materials. Generally, if you take the semiconducting materials, for those the energy band gap which is equals to the 0.2 electron volts to the 2.5 electron volts. What is energy band gap? So energy band gap is the energy difference between the conduction band and also the valency band. Energy difference between the conduction band and valency band is called as energy band gap. Okay, now classification of semiconductors. These semiconductors we are classifying into two categories. Okay, those are intrinsic semiconductors, and also the second one is extrinsic semiconductor. Intrinsic semiconductor and also the extrinsic semiconductor. These intrinsic semiconductors also called as a pure semiconductors, and extrinsic semiconductors are called as impure semiconductors. Why we are calling them intrinsic semiconductors are pure and extrinsic semiconductors are impure is, in this type of intrinsic semiconductor, it has a single atom. But to increase the electrical conductivity, we are adding the impurities for the intrinsic semiconductors. That is, we may add the boron or phosphorus, that type of atoms to the silicon or germanium semiconductors. Okay, first of all, I would like to tell about the intrinsic semiconductor. Intrinsic semiconductors in our periodic table, they are belongs to fourth. For example, if we take germanium, the atomic number for the germanium is 32. That means the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and also the 4p2. That means in n equals to 1 state, 2 electrons are there. In n equals to 2 state, 8 electrons are there. N equals to 3 states, so these 18 electrons. And n equals to 4 state, so 4 electrons are there. That means this one we may write like 4s2, 4p2. That means in a valency, how many electrons are there? 4 electrons are there. That's why that elements we are calling as a tetravalent atoms. Those are calling as a tetravalent atoms. Okay. Now, this type of semiconductor, if you take intrinsic semiconductor, it is a pure semiconductor. If you take that semiconductor, each and every surrounding atom is same kind of atom, and this germanium semiconductor, if you take that germanium, whatever the 4 valence electrons are there, they are participating in the covalent bonding with the surrounding atoms. Okay. Now we will see the structure of schematic diagram of a germanium. So germanium, for the germanium, how many electrons are there? In the valency, 4 electrons are there. So this is one germanium atom, this is another germanium atom. It has the 4 electrons in the valency. This is another germanium, and this is germanium. It has the 4 electrons in the valency. This is germanium. It has 4 electrons in the valency, and this is also a germanium. It is also having the 4 electrons, and germanium 1, 2, 3, 4. Germanium 1, 2, 3, 4. These all dots are indicating that single electrons. Okay. Now these single electrons are participating in the covalent bonding with the neighboring one. So like this. These are all participating in the bonding. At normal temperature, there are no charges to participate in the electrical conduction. While all the electrons are participating in the bonding, covalent bonding. So at normal temperature, these intrinsic semiconductors acts like a insulators. If we increase the temperature, the semiconductors are electrical conductivity is increases. That's why the semiconducting materials are called as negative temperature coefficients. They are having the negative temperature coefficient. Why? Conductors, if you increase the temperature for the conductors, resistivity increases. But if you take the semiconductors, if you increase the temperature, their conductivity increases. Why? Because whatever the bonding is there, the bonding will break. If one bond break, automatically 2 electrons will become like a single electron. I would like to draw the energy level diagram. So this is the energy level diagram. The electrons which are in the valency occupying the level, that is valency level, and in a solid state material, all these valency levels are forming like a valency band. This is the valency band. In this valency band, these valency electrons are exist. The energy corresponding to that, this is the energy, we are calling as a E suffix B. And if you supply the energy, that valency electrons will goes from the valency band to the next level. That level we are calling as a conduction level, and these are all forms like a band. That's why that is called as a conduction band. That is called as a conduction band. The energy corresponding to that one is a conduction. In between that, whatever the gap is there, this one we are calling as a energy band. That is EC equals to EC minus EV. For example, if you supply the energy, automatically bond will break. Now that time, the whatever the valency electron is there, that will take transition from valency bond to the conduction band. That means in the conduction band we will get the electron, in the valency band you will get a hole, vacant site. That vacant site we are calling as a hole. This vacant site is replaced by the neighboring electron. That means in in the total structure, these are in one direction electrons are going, in another direction holes are moving. Because of that, in semiconductors, the electrical conductivity is based on the electrons and also the holes. That's why in semiconductors, hole current is exist and also the electrical current is also exist. And also, suppose if we take the intrinsic semiconductor, for example, these are the electrons participating in the covalent bond. Once in the bond break, automatically these electrons will take transition from valence band to the conduction band. That time in the valence band you will get two holes. Okay, that means in the intrinsic semiconductor, number of electrons in conduction band is equals to the number of holes in valence band. That's it. Another kind of semiconductors are extrinsic semiconductors. Extrinsic. How can we obtain? And these are two types. One is p-type semiconductors and another one is n-type semiconductors. What we call as a p-type semiconductors and what we are calling as a n-type semiconductor. For example, if you take a pure semiconductor, that is silicon. This is silicon. Silicon is also having the 4 electrons in the valency. This is a silicon. Okay, each and every silicon atom has 4 electrons in the valency. So like this. Okay, those are participating in the covalent bond. Okay, so like this they are participating in the bonding. Now, if you are doping that material, doping means addition of impurities or adding of another type of material. For example, actually pure semiconductor belongs to 4th group. That means in the valency tetra, that means 4 valency electrons are there, tetravalent. Suppose if you take a boron, for boron atomic number is Z equals to 5. The electronic configuration is 1s2, 2s2 and 2p1. That means in the n equals to 2 state, how many electrons are there? 3. That's why this is belongs to 3rd group, and in the 3rd group 3 valence electrons are there. That's why these are called as trivalent. Okay, now for example, if you replace or if you doped with that one with the boron, so if you are doping that one with the boron, now just for understanding purpose I am replacing this silicon. Okay, if I remove the silicon, instead of silicon I am adding the boron. But boron has how many single electrons? Free electrons? 3. 1, 2, 3. What about this one? So is the hole is created there or not? Yes. If you are adding number of boron atoms, you will get number of holes. Number of holes. The holes charge is positive charge. Holes positive charge is positive charge. That means positive P. Okay, that means P. What does it mean? So in p-type semiconductor, majority charge carriers are okay, positive charge carriers holes, positive charges holes, minority charge carriers are electrons. That's it. Come to the n-type semiconductor. For n-type semiconductor, we can take either maybe a pure semiconductor, that is silicon or germanium. Yes, we know that silicon or germanium belongs to 4th group. Silicon or germanium belongs to 4th group. That means in the valency 4 electrons are there and those are participating in the electrical Okay, out of all those, so these are in covalent bonding. So this is the covalent bond, and this is also covalent bond. These are all covalent bonds. Okay. Now we can take the fifth group element. That means you can take the past plus. You can take the past plus. Past plus atomic number is, okay. Past plus atomic number is, that is 15. Past plus Z equals to 15. Electron configuration is 1s2, 2s2, 2p6, and 3s2, 3p3. That means in n equals to 3 state, okay, how many electrons are there? 5 electrons are there. That's why those are called as a penta. Penta means 5. Pentavalent atoms. Pentavalent atom. Now, if you replace a doping with the past plus, okay, you are replacing with past plus. Past plus in valence how many electrons? 5. Out of 5 electrons, 4 electrons are participating in the covalent bond. But there is one excess electron is there. There is one excess electron. If you doped with number of phosphorus atoms, you will get number of excess of negatively charged particles electrons. Just saying the type of semiconductors are called as n-type semiconductors. In n-type semiconductors, majority charge carriers are electrons.